Welcome to Wilton Hall, this magnificent venue where a lot of the things have happened historically, but perhaps this is one of the most historical meetings that might take place in this venue because what we're discussing is truly momentous. That the future of AI might define the future of humanity in ways that people had not anticipated and which we have not up till now thought carefully enough about. We have a wonderful set of speakers and panelists who will be sharing their thoughts in due course. My name is David Wood. I chair London Futurists. It's my pleasure to be hosting the event today. And we're going to start off with a presentation by somebody who has thought a great deal about the future of AI. He is Professor Stuart Russell from Berkeley. He has written a number of books on AI, including Human Compatible. And a couple of years ago, he was the presenter of a distinguished set of Wreath lectures here in the UK, where he anticipated the future of AI. But a week's a long time in politics, as they say, and 2 years is almost an eternity in terms of how many times AI has changed between now and then. So, Professor Stuart Russell, please bring us up to date. What should we be worried about, and what can we do to have a better future with AI? Stuart.
Thank you very much for the introduction. Okay, so my talk is going to start slowly and then speed up, which is sort of what's been happening over the last few years. Of course, it may not go at all. All right. So to get everyone on the same page, what is AI? It's about making machines intelligent. That's clear enough. And what does that mean? Well, what it has meant for most of the history of AI is that a machine is intelligent to the extent that its actions can be expected to achieve its objectives. And this borrows from centuries of development of the concept of rational behavior in philosophy and economics, and it extends to many other disciplines like control theory, operations research, statistics, economics, and so on. And the clear purpose of the field since the beginning has been what you might call general purpose AI. Some people call this AGI, systems that essentially can do anything that humans can do and do it at least as well, if not better. And there's pretty much consensus on the idea that if you achieve this, then because machines have far greater computing speed, memory, bandwidth, etc., they would very quickly exceed human capabilities along every dimension. So the next question then is, have we succeeded? And some people are arguing yes. In fact, my co-author on the textbook, Peter Norvig, just published a paper saying AGI is already here. And he qualifies that by saying, in the same sense that aviation was here once the Wright brothers were able to get an airplane to fly under its own power for a considerable distance. And to me, it's not clear, right? Are we at the Wright brothers stage, or are we at the Montgolfier stage, where we have a lot of hot air? And so my current view is, no, we have not succeeded. And the models that people are excited about, the large language models and their extensions into multimodal models that take in video and can actually operate robots and so on, that these are a piece of the puzzle. And CNN made this lovely animated GIF here to illustrate this idea that we don't really know what shape the piece of the puzzle is. And we don't know what other pieces are needed and how it fits together to make general purpose intelligence. We may discover what's going on inside the large language models. We may figure out what source of power they're drawing on to create the kinds of surprisingly capable behaviors that they do exhibit. But at the moment, that remains a mystery. And there are some gaps, right? One of the achievements of modern AI that people were most proud of and also most certain of was the defeat of human Go champions by AlphaGo and then AlphaZero in the 2016 to 2018 period. So in Go, for those of you who don't know, there's a board you put pieces on, and your goal is to surround territory and to surround your opponent's pieces and capture them. And since AI systems beat the world champion in 2017, they've gone on to leave human race in the dust. So the highest ranked program is CataGo, and its rating is about 5,200 compared to the human world champion at 3,800. And the human world champion leaves our colleague Kellen Pellerin, who's a grad student, a decent amateur Go player. His rating is about 2,300. And now I'll show you a game between Kellen and CataGo, where Kellen actually gives CataGo a 9-stone handicap. So CataGo is black and starts with 9 stones on the board, right? If you're an adult Go player and you're teaching a 5-year-old how to play Go, you give them a 9-stone handicap so that at least they can stay in the game for a few minutes, right? So here we are treating CataGo as if it's a baby, okay? Despite the fact that it's massively superhuman. And here's the game. So it's speeded up a little bit, but watch what happens in the bottom right corner. So White, the human being, is going to start building a little group of stones. There they go. And then Black very quickly surrounds that group to make sure that it can't grow, and also to actually have a pretty good chance of capturing that group. But now White starts to surround the black stones. And interestingly, Black doesn't seem to pay any attention to this. It doesn't understand that the black stones are in danger of being captured, which is a very basic thing, right? You have to understand when your opponent is going to capture your pieces. And Black just pays no attention and loses all of those pieces, poof, and that's the end of the game. So something weird happens there, right? Where an ordinary human amateur Go player can beat a Go program that's stratospherically better than any human being has ever been in history, right? And in fact, the Go programs do not correctly understand what it means for a group of stones to be alive or dead, which is the most basic concept in the game of Go. They have only a limited fragmentary approximation to the definition of life and death. And that's actually a symptom of one of the weaknesses of training circuits to learn these concepts. Circuits are a terrible representation for concepts such as life and death, which can be written down in Python in a couple of lines, can be written in logic in a couple of lines. But in circuit form, you can't actually write a correct definition of life and death at all. You can only write finite approximations to it. And the systems are not learning a very good approximation, and so they are very vulnerable. And this turns out to be applicable not just to CataGo, but to all the other leading Go programs, which are trained by completely different teams on completely different data using different training regimes, but they all fail against this very simple strategy. So this suggests that actually the systems that we have been building we are overrating them in a real sense, and I think that's important to understand. And human beings, right, another way to make this argument is to look at things that humans can do. For example, we can build the Large Interferometric Gravitational Observatory. So these are black holes colliding on the other side of the universe. This is the LIGO detector, and which is several kilometers long. It's full of physics and is able to detect distortions of space down to the 18th decimal place, and was able to actually measure exactly what the physicists predicted would be the shape of the waveform arriving from the collision of two black holes, and was even able to measure the masses of the black holes on the other side of the universe when they collided. So could ChatGPT do this? Could any deep learning system do this, given that there are exactly 0 training examples of a gravitational wave detector? I think at the moment there is still a long way to go. On the other hand, people are extremely ingenious, and people are working on hybrids of large language models with reasoning and planning engines that could start to exhibit these capabilities quite soon. So people I respect a great deal think we might only have 5 years until this happens. Almost everyone has now gone from 30 to 50 years, which was the estimate a decade ago, to 5 to 20 years, which is the estimate right now. So unlike fusion, this is getting closer and closer and closer rather than further and further into the future. So we have to ask, what happens if we actually succeed in creating general purpose AI? And the reason we're trying to do it is because it could be so transformative to human civilization. Very crudely, our civilization results from our intelligence. If we have access to a lot more, we could have a lot better civilization. One thing we could do is simply deliver what we already know how to deliver, which is a nice middle-class standard of living, if you want to think of it that way. We could deliver that to everyone on Earth at almost no cost. And that would be about a 10-fold increase in GDP. And the net present value of that is $13.5 quadrillion. So that's a lower bound on the cash value of creating general purpose AI. So if you want to understand why we're investing hundreds of billions of pounds in it, it's because the value is millions of times larger than that. And so that creates a magnet in the future that is pulling us forward inexorably. My friend Jaan Tallinn here likes to call this Moloch, right? The sort of ineluctable force that draws people towards something even though they know that it could be their own destruction. And we could actually have an even better civilization, right? We could have we could one day have a clicker that works. We could have healthcare that's a lot better than we do now. We could have education that could be brought to every child on Earth that would exceed what we can get from even a professional human tutor. This, I think, is the thing that is most feasible for us to do that would benefit the world in this decade. And I think this is entirely possible. Healthcare is actually a lot more difficult for all kinds of reasons, but education is a digital good that can be delivered successfully. And we could also have much better progress in science and so on. So on the other hand, AI amplifies a lot of difficult issues that policymakers have been facing for quite a while. So one is its ability to magnify the pollution of our information ecosystem with disinformation, what some people call truth decay. And this is happening at speed. But if we thought about it really hard, AI could actually help in the other direction. It could help clean up the information ecosystem. It could be used as a detector of misinformation, as something that assembled consensus truth and made it available to people. We're not using it in that way, but we could. Ditto with democracy. Is it being suppressed by surveillance and control mechanisms? Or could we use AI systems to strengthen it, to allow people to deliberate, cooperate, and reach consensus on what to do? Could it be that individuals are empowered, or the current trajectory that we're on, individuals being enfeebled as we gradually take over more and more of the functions of civilization, and humans lose the ability to even run their own civilization as individuals, right? These are important questions that we have to address while we're considering all of the safety issues that I'll be getting to soon. There's inequality. Right now, we're on the path of magnifying it with AI, but it doesn't have to be that way, and so on. I won't go through all of these issues because they're all, each of them, worthy of an entire talk in themselves. So I would say the sort of the mid-term question is, what are humans going to be doing, right? If we have general purpose AI that can do all the tasks or nearly all the tasks that human beings get paid for right now, what will humans do? And this is not a new issue. Aristotle talked about it in 350 BC. Keynes, since we're in Milton, it's odd that we pronounce it Milton Keynes, but his name is pronounced Keynes, even though the town is named after him. So Keynes in 1930 said, thus for the first time since his creation, man will be faced with his permanent problem, how to use his freedom from pressing economic cares which science will have won for him to live wisely and agreeably and well. So this is a really important problem, and again, this is one that policymakers are misunderstanding, I would say. The default answer in most governments around the world is, we'll retrain everyone to be a data scientist. As if somehow the world needs 4 billion data scientists. I think that's probably not the answer. But this is, again, the default path is one of enfeeblement, which is illustrated really well by Wall-E. So my answer to this question is that in the future, if we are successful in building AI that is safe, that does a lot of the tasks that we want done for us, most human beings are going to be in these interpersonal roles. And for those roles to be effective, they have to be based on understanding, right? Why is a surgeon effective at fixing a broken leg? Because we have done centuries of research in medicine and surgery to make that a very effective profession. And in some countries very highly paid and very prestigious. But most interpersonal roles, for example, think about childcare or elder care, are not highly paid, not highly prestigious, because they are based on no science whatsoever. Despite the fact that our children are our most precious possessions, as politicians like to say a lot. In fact, we don't understand how to look after children. We don't understand how to make people's lives better. So this is a very different direction for science, much more focused on the human than on the physical world. Okay. So now, let me move on, if I can get the next slide up, to Alan Turing's view of all this. What happens if we succeed? He said that it seems probable that once a machine thinking method has started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. So he said this in 1951. And to a first approximation, for the next 70-odd years, we paid very little attention to what his warning was. And I used to illustrate this with the following imaginary email conversation. So an alien civilization sends email to the human race, humanity@un.org. Be warned, we shall arrive in 30 to 50 years. That was what most AI people thought back then. Now we would say maybe 10 to 20 years. And humanity replies, humanity is currently out of the office. We will respond to your message when we return. And then there should be a smiley face. There it is. Okay. So that's now changed. Unfortunately, that slide wasn't supposed to come up like that. Let me see if we can, oh well, can't fix it now. So I think early on this year, 3 things happened in very quick succession. So GPT-4 was released, and then Microsoft, which had been working with GPT-4 for several months at that point, published a paper saying that GPT-4 exhibited sparks of artificial general intelligence, exactly what Turing warned us about. And then FLI released the open letter asking for a pause on giant AI experiments. And I think at that point, very clearly, humanity returned to the office and they saw the emails from the aliens. And the reaction since then, I think, has been somewhat similar to what would happen if we really did get an email from the aliens. There have been global calls for action. The very next day, UNESCO responded directly to the open letter, asking all its member governments, which is all the countries on Earth, to immediately implement the AI principles in legislation, in particular principles that talk about robustness, safety, predictability, and so on. And then, there's China's AI regulations. The US got into the act very quickly. The White House called an emergency meeting of AI CEOs, OpenAI calling for governments to regulate AI, and so on. And I ran out of room on the slide on June 7th with Rishi Sunak announcing the Global Summit on AI Safety, which is happening tomorrow. So lots of other stuff has happened since then. But it's really, I would say, to the credit of governments around the world, how quickly they have changed their position on this. For the most part, governments were saying, regulation stifles innovation. If someone did mention risk, it was either dismissed or viewed as something that was easily taken care of by the market, by liability, and so on. So I would say that the view, the understanding has changed dramatically, and that could not have happened without the fact that politicians started to use ChatGPT, and they saw it for themselves. And I think that changed people's minds. So the question we have to face then is this one, right? How do we retain power over entities more powerful than ourselves forever, right? And I think this is the question that Turing asked himself and gave that answer. We would have to expect them to take control. So in other words, this question doesn't have an answer. But I think there's another version of the question which works somewhat more to our advantage. And it should appear any second, right? And it has to do with how we define what we're trying to do. What is the system that we're building? What problem is it solving? And we want a problem such that we set up an AI system to solve that problem. So the standard model that I gave you earlier was systems whose actions can be expected to achieve their objectives. And that's exactly where things go wrong, that systems are pursuing objectives that are not aligned with what humans want the future to be like, and then you're setting up a chess match between humanity and a machine that's pursuing a misaligned objective. So instead, we want to figure out a problem whose solution is such that we're happy for AI systems to instantiate that solution. Okay. And it's not imitating human behavior, which is what we're training LLMs to do. That's actually a fundamental and basic error. And that's essentially why we can't make LLMs safe, because we have trained them to not be safe. And trying to put sticking plasters on all the problems after the fact is never going to work. So instead, I think we have to build systems that are provably beneficial to humans. And the way I'm thinking about that currently is that the system should act in the best interests of humans, but be explicitly uncertain about what those best interests are. And this I'm just telling you in English, and it can be written in a formal framework called an assistance game. So what we do is we build assistance game solvers. We don't build objective maximizers, which is what we have been doing up to now. We build assistance game solvers. This is a different kind of AI system, and we've only been able to build very simple ones so far, so we have a long way to go. But when you build those systems and look at the solutions, they exhibit the properties that we want from AI systems. They will defer to human beings, and in the extreme case, they will allow themselves to be switched off. In fact, they want to be switched off if we want to switch them off, because they want to avoid doing whatever it is that is making us upset. They don't know what it is, because they're uncertain about our preferences, but they want to avoid upsetting us, and so they are happy to be switched off. In fact, this is a mathematical theorem. They have a positive incentive to allow themselves to be switched off. And that incentive is connected directly to number 2, right? The uncertainty about human preferences. So, there's a long way to go, as I said, and we're not ready to say, okay, everyone in all these companies, stop doing what you're doing and start building these things instead, right? That probably is not going to go down too well, because we don't really know how to build these things at scale and to deliver economic value. But in the long run, this is the right way to build AI systems. So in between, what should we do? And this is a lot about what's going to be discussed tomorrow. And there's a lot. So this is in a small font. I apologize to those of you at the back. There's a lot to put on this slide. We need, first of all, cooperation on AI safety research. It's got to stop being a cottage industry with a few little academic centers here and there. It's also got to stop being what a cynic might describe as a kind of whitewashing operation in companies, where they try to avoid the worst public relations disasters, like, the language model used a bad word or something like that. But in fact, those efforts have not yielded any real safety whatsoever. So there's a great deal of research to do on alignment, which is what I just described, on containment. How do you get systems that are restricted in their capabilities, that are not directly connected to email and bank accounts and credit cards and social media and all those things? And if there are, I think there are probably ways of building restricted capability systems that are provably safe because they are restricted to only operate provably sound reasoning engines, for example. But the bigger point is, stop thinking about making AI safe. Start thinking about making safe AI. Right? These are just two different mindsets. The making AI safe says we build the AI and then we have a safety team whose job it is to stop it from behaving badly. That hasn't worked, and it's never going to work. We have got to have AI systems that are safe by design. And without that, we are lost. We also need, I think, some international regulatory level to coordinate the regulations that are going to be in place across the various national regimes. So we have to start probably with national regulation, and we can coordinate very easily. For example, we could start coordinating tomorrow to agree on what would be a baseline for regulation. I put a couple of other things there that went by too quickly, so I actually want to go back. Okay, too far. All right. So the light blue line, transparent, explainable, analytical substrate, is really important. At the moment, we're building AI systems that are black boxes. We have no idea how they work. We have no idea what they're going to do. And we have no idea how to get them to behave themselves properly. So my guess is that if we define regulations appropriately so that companies have to build AI systems that they understand and predict and control successfully, those AI systems are going to be based on a very different technology, not giant black box circuits that are trained on vast quantities of data, but actually well understood component-based systems that build on centuries of research in logic and probability, where we can actually prove that these systems are going to behave in certain ways. The second thing, the dark blue, secure PCC-based digital ecosystem, what is that? So PCC is proof-carrying code. And what we need here is a way of preventing bad actors from deploying unsafe systems. So it's one thing to say, here's how you build safe systems, and everyone has to do that. It's another thing to say, how do you stop people from deploying unsafe systems who don't want safe AI systems, they want whatever they want. This is probably even more difficult. Policing software is, I think, impossible. So the place where we do have control is at the hardware level, because hardware, first of all, to build your own hardware costs about $100 billion and tens of thousands of highly trained engineers. So it provides a control point that's very difficult for bad actors to get around. And what the hardware should do is basically check the proof of a software object before it's run and check that, in fact, this is a safe piece of software to run. And proof-carrying code is a technology that allows hardware to check proofs very efficiently. But of course, the onus then is on the developer to provide a proof that their system is in fact safe. And so that's a prerequisite for this approach. Okay. Let me talk a little bit about regulations. So a number of acts already in the works. For example, the European AI Act has a hard ban on the impersonation of human beings. So you have a right to know if you're interacting with a machine or a human. This, to me, is the easiest, the lowest hanging fruit that every jurisdiction in the world could implement pretty much tomorrow if they so decided. And I believe that this is how legislators wake up those long unused muscles that have lain dormant for decades while technology has just moved ahead unregulated. So this is the place to start. But we also need some regulations on the design of AI systems specifically. So a provably operable kill switch is a really important and basic thing. If your system is misbehaving, there has to be a way to turn it off. And this has to apply not just to the system that you made, but if it's an open source system, any copy of that system. And that means that the kill switch has got to be remotely operable, and it's got to be non-removable. So that's a technological requirement on open source systems. And in fact, if you want to be in the open source business, you're going to have to figure this out. You're actually going to subject yourself to more regulatory controls than people who operate on closed source. And that's exactly as it should be. Imagine if we had open source enriched uranium, right? And the purveyor of enriched uranium was responsible for all the enriched uranium that they purveyed to anybody around the world. They're going to have a higher regulatory burden because that's a blinking stupid thing to do, right? And so you would expect there to be a higher burden if you're going to do blinking stupid things. And then red lines. This is probably the most important thing. So we don't know how to define safety. So I can't write a law saying your system has to be provably safe, because it's very hard to write the dividing line between safe and unsafe. You know, if you, Asimov's law, you can't harm human beings. Well, what does harm mean? That's very hard to define. But we can scoop out very specific forms of harm that are absolutely unacceptable. So self-replication of computer systems would absolutely be unacceptable. That would be basically a harbinger of losing human control if the system can copy itself onto other computers or break into other computer systems. Absolutely, systems should not be advising terrorists on building biological weapons, and so on. So these red lines are things that any normal person would think, well, obviously, the software system should not be doing that. And the developers are going to say, oh, well, this is really unfair because it's really hard to make our systems not do this. And the response is, well, tough, right? Really? You're spending hundreds of billions of pounds on this system and you can't stop it from advising terrorists on building bioweapons? Well, then you shouldn't be in business at all, right? This is not hard, and legislators, by implementing these red lines, would put the onus on the developer to understand how their own systems work and to be able to predict and control their behavior, which is an absolute minimum we should ask from any industry, let alone one that could have such a massive impact and is hoping for quadrillions of dollars in profits. Thank you.
Thank you very much, Professor Russell. Quick question, maybe, before we move on to the next speaker. There was some good news in there. It is that we have ideas on how to make safe AI. But how long do you think we're going to need? How long is it going to take by default that we have these ideas worked out? And how long might it take if we had all the smart people in the world give up their current focus and instead work on this?
I think these are really important questions because the political dynamic is going to depend to some extent on how the AI safety community responds to this challenge. Because if the AI safety community fails to make progress on any of this stuff, the developers can point and say, look, you know, you guys are asking for stuff that isn't really possible, and we should be allowed to just do what we want. But if you look at the nuclear industry, right, how does that work? The regulator says to the nuclear plant operator, show me that your plant has a mean time to failure of 10 million years or more. And the operator has to give them a full analysis with fault trees and probabilistic calculations, and the regulator can push back and say, you know, I don't agree with that independence assumption. You know, these components come from the same manufacturer, so they're not independent, and come back with a better analysis and so on. At the moment, there is nothing like that in the AI industry. There is no logical connection between any of the evidence that people are providing and a claim that the system is actually going to be safe, right? That argument is just missing. Now, the nuclear industry probably spends more than 90% of its R&D budget on safety. One way you can tell, I got this statistic from one of my nuclear engineering colleagues, that for the typical nuclear plant in the US, for every kilogram of nuclear plant, there are 7 kilograms of regulatory paperwork. I kid you not. So that tells you something about how much of an emphasis there has been on safety in that industry. And also, you know, why is there, to a first approximation, no nuclear industry today? Is because of Chernobyl and because of a failure in safety, actually deliberately bypassing safety measures that they knew were necessary in order to save money.
We'll take one question from the audience, provided it's a quick question. I see a hand over there. Let me...
My name is Charlie. I'm a student at UCL. One of the big reasons, I think, why there's so much regulation on nuclear power is widespread public opinion and protests against nuclear power from within the environmental movement. So I wondered whether you thought if there's a similar role for public pressure or protests for AI as well.
I think that's a very important question. My sense is, I'm not really a historian of the nuclear industry per se. Obviously, nuclear physicists thought about safety from the beginning. In fact, so Leo Szilard was the one who invented the basic idea of the nuclear chain reaction. And he instantly thought about a physical mechanism that could keep the reaction from going supercritical and becoming a bomb, right? So he thought about this, you know, negative feedback control system with moderators that would somehow keep the reaction subcritical. People in AI are not at that stage, right? Or they just have their eyes on, you know, we can generate energy, and they're not even thinking, you know, is that energy going to be in the form of a bomb or electricity, right? They haven't got to that stage yet. So we are very much at the preliminary stage. I do worry that AI should not be politicized. And at the moment, there's a precarious bipartisan agreement in the US and to some extent in Europe. I worry about that breaking down in the UK. I think it's really important that the political message be very straightforward. You can be on the side of humans, or you can be on the side of our AI overlords. Which do you want to be on? And so let's try to keep it a unified message around developing technology in a way that's safe and beneficial for humans.
So we can raise awareness, but we shouldn't do it in a partisan way.
Yes, and what I totally sympathize with the idea that people have a right to be very upset that, you know, that multi-billionaires are playing, playing poker with the future of the human race. It's entirely reasonable. But what I worry is exactly that certain types of protest end up getting aligned in a way that's unhealthy. It sort of becomes anti-technology. And we can look back at what happened with GM organisms, for example, which most scientists think didn't go the way it should have, and we lost benefits without gaining any safety.
Lots to think about there. Thank you very much, Professor Stuart Russell.
Thank you.
We may give you the microphone again a bit later on, but there's lots of other people we want to hear from now. So the next speaker is Connor Leahy, who is the CEO of Conjecture. Many of us got a shock with GPT-4 or 3.5. My goodness, what's going on here? Connor was ahead of the curve when he saw GPT-2 with all its warts and weaknesses. He said, my gosh, this is going to change the world. So he has been thinking about some of these issues, probably for longer than the rest of us. So let's hear from Connor. What would you like to say?
Thank you so much. So unfortunately, Professor Russell has stolen my favorite Alan Turing quote, so you're going to be hearing that one again. But I guess there couldn't be a more appropriate time. Because many years ago, there lived a man named Alan Turing. He was the godfather of computer science, a titan in his field, and a hero of World War II. And it was here at Bletchley Park that he did his most seminal work during the World War II on cracking the codes that the Germans were using, and as a very early step into the field of computer science. And Alan was ahead of his time in more ways than one. In 1951, in Manchester, he gave a lecture entitled Intelligent Machinery, a Heretical Theory. And in this lecture, he said, "For it seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. There would be no question of the machines dying, and it would be able to converse with each other to sharpen their wits. At some stage, therefore, we should have to expect the machines to take control." And here we are, 72 years later, where it all began. And a lot has changed since the days of Alan Turing. Computers have improved at incredible rates. I'm holding in my hands right now a computer of such incredible power that it would be barely imaginable to Turing and his contemporaries. Barely one human lifetime hence. And while computers have advanced a lot in many ways since the days of Turing, I like to believe that there would be a lot he would recognize. He would recognize the basic functions of computers, their memory, their instructions, programming, code, ideas that go all the way back to his seminal work on Turing machines. While he might not be familiar with the exact tooling, he would be familiar with the general concepts around modern programming, where a programmer writes code, instructions, the computer then executes. But there is something that I'm not so sure he would so easily recognize. And that is AI, or in particular, the neural networks that power them. Now, we have all seen AI do truly amazing things over the last couple of years in particular, solving all these problems that previously we barely knew how to approach. And you might think, when you look at all these AI systems running on your phone or on your computer, that this is software like any other, written by very clever programmers to do the useful and the marvelous things that they do. And you would be wrong. Because AI is very different from normal software. It is not written so much as it is grown. So while in the traditional software you'd have a programmer sit down and write out the instruction, with AIs you take huge supercomputers and massive data sets, and you use these supercomputers to grow a program on your data to solve your problem. And this works really well for many issues. It has improved our ability to solve many very useful tasks and do many things that we did not know how to do before. And our ability to grow these AIs continues to improve and get better and better. While at the same time, though, our ability to understand our AIs has not. Because these AIs are not like well-written code that a human could read. They're more like giant blobs of numbers. And we know if we execute them, they work. But we have no idea why. And only quite recently have we discovered that as we scale up these systems, as we build bigger computers, bigger AI systems, something quite remarkable happens. They become more intelligent, more capable. Now, of course, there are many details that have to be gotten right. There are many parameters you have to set correctly. You have to have enough data. You have to make sure your computer is set up correctly. But fundamentally, there is a stability in this prediction, sometimes also called the scaling laws, in that as our systems become bigger, as our computers become more powerful, the systems learn higher and higher order patterns, more and more complex skills, knowledge, abilities. And as they become more powerful and more capable, they are also becoming even harder to understand and to control. And this is why we are all here today. Back to where it all began, we have now returned, Bletchley Park. Because as Turing already realized, it is really quite simple. If we build machines that are more competent than us at manipulation, perception, politics, business, science, and everything else, and we do not control them, then the future will belong to the machines, not to humans. And the machines are unlikely to feel particularly sentimental about keeping us around for very long. And so here we are, faced with an exponentially increasing, more powerful by the day, AI by the day. And as we learned with COVID, there are exactly 2 times one can react to an exponential: too early or too late. If we wait until AGI, if we wait until we see these self-improving, powerful, general-purpose systems, it will be too late. Far, far too late. And this is why I am so happy to see the UK government take leadership in the first of many important steps towards the necessary international coordination to address this extinction-level threat that is facing us all. And the very first step, as so many academics, industry leaders, and even governments have already taken, is to firmly acknowledge the reality of what we face, the potential extinction of our species by AI. Private AI companies are scaling their AI systems as we speak, and they will not ask for permission, and they will not stop unless we make them. They are already lobbying our governments with ineffective policies, such as responsible scaling, in an attempt to prevent actually effective policy. Like the oil CEOs of the past, trying to lobby against climate change regulation that would hurt their bottom lines. The good news is that it's not yet too late to stop this, to prevent the building of such deadly machines until we know how to build them safely. That is why there is nothing more important than for people to know the truth. That a small group of unelected, unaccountable, private companies are running a deadly experiment on you, on your family, and on everyone on Earth, without your consent or even knowledge, despite they themselves admitting that these risks are real. At this point, all of us agree that we are playing Russian roulette with the entire planet. And we're only quibbling about how many poles are left until the bullet. Now, in my personal opinion, if you ever find yourself playing Russian roulette, I suggest you put down the gun. And so, we have to speak up and demand action if we want a future for us, our children, and our species. It's not yet too late, but it will be soon. We stand at a historic moment today at where it all began, Bletchley Park. Let's not waste it.
Thank you, Connor. Let's take a couple of questions from the audience. Where am I seeing? There's one at, yeah, if you take the microphone in there, thanks.
Hi, very nice presentation, by the way. I wanted to ask, with the current situation that's going on with AI currently, do you really think, if you were to be a philosopher maybe for 5 minutes, do you really think that currently society is really ready for it? I mean, sure, we can adapt in somewhat, but as things are developing around us, it doesn't seem like we're really anywhere near to, accepting it. We're just as such fear and and other factors coming on.
Yes, so the simple answer is no. We're absolutely not ready. We are children playing with nuclear fire or worse. Our civilization does not have the level of maturity to be able to handle technology like this, and this is why I'm not extremely optimistic about the future. The truth is that whether it's AI or something else, technology is becoming more and more powerful. This is just how it is. This is how technology works. And our society has to adapt to this. If we as a society do not find a way to, as an entire civilization, as an international civilization, work together in a way that we can responsibly steward technology so powerful that it can destroy anything, then humanity is on a timer. Whether it's AGI or whatever comes after that, we need to improve our society, or that's it.
Sometimes people grow up in a hurry. Sometimes people are a bit childish and suddenly there's a big threat ahead and my goodness, we grow up. Is that what you see happening with humanity now? We're not ready for AGI, but as we understand the risks, we will change our mode of operation.
I sure hope so. And if it happens, it will not happen as a side effect. It will be because people do something about it. It's because people, like the people in this room, actually do something about it, stand up, and make a difference in our institutions and our society. There is no law of physics that forbids us from having a good future, from taking control of our future and building wonderful, safe technology for all. But there is also no law that mandates it.
I saw one more hand up. Yes, if you give the mic to the woman in the glasses. Thank you.
I was going to say, I know that one of your policies is that you want to cap compute. And I'm just wondering whether you are going to suggest that at the summit and what you think the government's response to that will be.
Compute caps are absolutely the most sensible direct policy for us as a species to follow. The main reason for this is that it is the bottleneck towards building the actually existential dangerous systems.
Just explain what these view caps are.
Yes, so compute caps is basically limiting the maximum size of those supercomputers I talked about. We limit the maximum size our AIs and our computers are allowed to be. And so we can limit, hypothetically, how intelligent they will be. The problem is, of course, that we don't know where the real limit is. We don't know when things actually get dangerous, because we don't know what pops out of our experiments until we run them. So it might already be that we're already too late. Our computers might already be big enough to end the world. We don't know, but hopefully not. And in that case, as I say with Russian roulette, if you pulled the trigger once and there was no bullet, the correct move is not to pull it again. The first thing you do is don't pull it again until you know if there's a bullet and where it is. And if you know there's one, definitely don't pull it. So this is my opinion on this. I will definitely be open to talking and would like to suggest this to all policymakers of all nations, needless to say. I think there is extremely strong resistance to this for the obvious reason that this cuts into the bottom lines of very powerful big tech companies who have extreme lobbying power and control over governments. This is, well, I mean, it's very simple. There's a lot of people who gain a lot of benefits from continuing to pull that trigger. And we have to make them stop. And they are going to fight us every step of the way. It's just how that works.
Thank you very much, Connor Leahy. And I'd like to invite the 8 members of the panel to come up on stage. And we're going to continue the conversation. Please self-organize on the seats. Stuart, I don't think we've got a seat for you at this stage. We can either find another seat for you or we'll let you come back on the stage later. So sit down in whichever system you like, and we will hear from each of these panelists what they think has been missing from the conversation so far. Maybe they've got an alternative view. Maybe they don't think we're playing Russian roulette and a different metaphor is appropriate. Maybe they would like to express what they think the politicians they're closest to should be saying. Maybe they'd like to comment on some of the other issues of safety. So, shall we start at the far end there? And let's just move along the panel. I'll give you 2 minutes each to contribute what you'd like into this conversation, and then we'll hear from the audience. So,
Sure, I can do that. My name is Mark Brakel. I'm the Director of Policy at the Future of Life Institute. And to really support what Stuart and Connor have been saying, I think when we looked at the summit about 6-7 weeks ago, we put out a set of recommendations ahead of time. And I think there were 3 traps that we identified that we were worried the summit would fall into. The summit potentially not addressing the full range of risks, all the way from bias and discrimination up to extinction, it not being inclusive, namely China not being invited, and it being a setting where the big CEOs would sort of run the show and there would be maybe some token academics at a panel in a room the night before. So I think if we sort of assess what the summit is looking like now, the night before the actual event, I think sort of we can be reasonably happy. I saw this morning that China will, in fact, be invited, and that it will be an inclusive summit in that all nations of the world will get a seat at the table. So I think that's progress, so that's very good. If we think about the harms and the range of harms that are being discussed, one of the things FLI recommended for the summit was grounding it in examples of large-scale AI harm that we've already seen, such as the Australian robo-debt scandal or the Dutch benefit scandal. I'm from the Netherlands myself, and it's a political scandal really dominating the national scene, to show that very simple algorithms can already have a very large impact in countries that were rushing towards adoption, and to show the beginning of the trend line. That hasn't happened. I think that's potentially a missed opportunity, but I think it's really good where the UK has overall focused the summit. And I think I'm sort of least optimistic when it comes to the role of companies at the summit. And I think Connor's done a great job at highlighting concerns that FLI, that many of us have around responsible scaling, and this narrative being pushed by many companies as an excuse to keep going, rather than making sure that whatever they put out onto the market is actually safe. And I think that's a message that I hope we collectively and the people in this room that are going to the summit can still take to the participants and to the governments that are there, making sure that we put the onus of what is safe and what isn't safe on the companies. They need to prove to us that what they're putting on the market is safe, rather than the other way around, where the default is they keep on scaling and it's up to the regulator to prove that what is safe. So that, I think, is a key message to take away.
So you're giving at least 2 cheers, if not 3 cheers, to the organizers for what you see happening already. So from one Dutchman to another, Ron Roozendaal is the Deputy Director General of the Netherlands Ministry for the Interior, lots of other roles. What would you like to add to the conversation, Ron?
Well, thank you very much, and I'm glad to be here. First point is that we regulate cars and we regulate pharmaceuticals. And we do so to mitigate the risks of today and the risks of tomorrow. So we have to act upon risks of today, like bias, and risks of tomorrow. And those are global risks. So we welcome the initiative of the summit, but we also welcome the initiative of the Tech Envoy of the UN, starting a high-level advisory board. And we have offered the Tech Envoy to host a European meeting of the high-level advisory board in The Hague, for example, in the Peace Palace, because we support the work that we all do internationally to mitigate the risks. Secondly, we need some form of early warning, whatever the risks are, and whether they will occur or not. We have to have early warning and a rapid response mechanism on whatever will happen in the future, and therefore we need to operate in a value-driven way. We need to participate, we need to coordinate, but we also need to cooperate with industry, with civil society, with citizens, with industry, and with government.
Agreement on early warning seems like something that both sides of the debate should be able to give, because the people who think things will go wrong and the people who think things won't go wrong should be able to agree, well, if this happens, we should all be paying more attention. Let's pass the microphone on to Hal Hodson, who's a journalist at The Economist who has written a lot about existential risks and AI. Hal.
Thanks, David. Yes, so my name's Hal Hodson. I'm a special projects writer with The Economist. I've been writing about AI for 10 years. I have a degree in astrophysics, and that meant that I spent a lot of time looking at a thing called the archive, long before it was cool. And papers from Facebook and Google would just turn up on the archive with no PR whatsoever, and this is journalistic gold, and that's how I got into it. I guess my sort of view is inherently going to be journalistic. I think it is a very difficult point to make very clear decisions about what anybody ought to do about any of this. I think from my perspective, there's a huge amount of uncertainty. I've now been writing about it long enough to know that there's also a lot of hype, and it's not the first time there's been a huge amount of hype. And I think making very clear decisions about important systems at a time that is hype-filled is a difficult thing to do. I think the thing that I can agree on, the consensus that I can come to with probably most of the people in the room and the organizers of the summit, is that there's a huge amount of science to do. And both in terms of existential risks and these sort of lower tier algorithmic risks, I think there's two examples that show us that this is a perfectly plausible thing to do. The first is that there was a time in the 90s when everybody was very worried about impact of bodies in the solar system to Earth, existential risks from asteroids and things like this. And Congress mandated a large amount of money to go to NASA to map all of the asteroids in the solar system and to figure out ways to nudge them off course if they come towards us. And if you look at the risks as they were assessed in the 90s, and the risks as they are assessed today, they are massively, massively, dramatically lower. And so that, to me, is a very strong case for doing science on these risks. I don't know, and I'd be fascinated to talk to people who do know what doing science on AI systems really looks like. But it brings me to the next comparison, which is Facebook. About 5 years ago, there was also a big panic that Facebook was determining the results of elections or, hacking democracy, essentially. That has somewhat subsided now, but one of the most sensible responses to that concern that I saw was also that you need to do science on Facebook just like you needed to do science on the solar system. You need to start measuring things. And it actually took years to force Facebook to give access to data to people like Social Science One. It eventually sort of worked, and I think there's a reason that you don't hear a huge amount about it. It's because the science that's been done so far has not determined that Facebook destroyed democracy. We still have at least a version of it. And so I guess I would end just by a plea to, and perhaps in the same way you were saying, Stuart, politically neutral science to the extent that that's possible, more of a goal than a thing that exists.
And do you happen to know whether the US focus on asteroid risk in the 90s, was that bipartisan or was that a partisan issue?
I don't know if it was bipartisan, but it went through Congress, so it must have been a bit bipartisan.
So some
Or
encouraging
maybe it wasn't as
examples
bad
there.
back then, actually, now that I think of it.
There's some encouraging examples there. Next, we're going to hear from Annika Brack, who's the CEO of the International Centre for Future Generations. Tell us about your views, Annika.
Yes, thank you very much. And first of all, I'd like to commend the UK on two things. First of all, their sense of humor for setting up a summit on the darkest corners of AI on the night of Halloween or the nights after. And I'm surprised nobody made that joke so far. And secondly, for really bringing this to the attention of leaders, media, and the public, actually. I don't think Frontier AI has ever been discussed so much, and the number of communiques, the number of, the executive order, the communications leaders, European leaders meeting ahead of the summit, negotiating late night to get to bring something here is already a measure of success. And we could actually leave it here with this stellar panel and say, I think it's very important that the civil society is meeting here. This is maybe the element that is missing in the room. I'd like to say we have two major challenges here. One is a coordination challenge. We have corporates looking at the topic. They're racing over competitive edge. And we have governments who have serious geostrategic interest. And when those two come together, that doesn't help collaboration. So we have to think about how we get people around the table. And secondly, there's a democratic challenge. Democracy is, by its very nature, a slow and patient regulator. And that's important. I will argue that actually democracy is perfectly adapted to steer society through these uncharted waters that we are experiencing at the moment. But we need to make sure that the sailors of this big ship are prepared, that they are well informed, and that they have the tools to deal with this change. And that's what the International Centre for Future Generations set out to do in Brussels. That's why we moved our headquarters to Brussels, to make sure that EU decision makers are well prepared, because we set our best hope in the EU in this international race for governance. I will leave it here for now.
Are the EU decision makers paying attention to what you say?
I think they do. You do hear already a lot of signs that they have also recognized that we have to look at advanced artificial intelligence, that regulation doesn't stop with the Artificial Intelligence Act. It's only the very start of the beginning, or the first piece of the puzzle, to come back to Stuart's presentation.
Thanks. Next, we're going to hear from Jaan Tallinn, who is the co-founder of Skype, FLI, CSER, that's the Centre for the Study of Existential Risks, and he is also one of the advisors on the committee created by the Tech Envoy for the UN. So, Jaan, what would you like to say based on what you've heard so far?
Thank you very much. Sometimes people ask me, because I've been in this kind of existential risk and AI safety community and effort for more than a decade now, sometimes people ask, like, so how's it going? And my standard answer is, well, it's great progress against an unknown deadline. And indeed, like, it's especially this year, it's there's like a plethora of things to point to as great progress. And obviously, the most obvious one to point to at this point is the summit that starts tomorrow. I do think UK deserves a great credit for pulling this together, and I really wish kind of best of luck to the organizers of this, and Prime Minister as well, and the team. Now, when it comes to this like unknown deadline, recently I kind of pivoted away to some degree from basically funding research towards just buying us more time, which is kind of has to deal with something like less research side and more kind of on an action side, more on a policy side. So I do think it's kind of valuable now to really think through the policy that would make the future kind of a little bit less unknown and the deadlines a little bit less unknown. Another and final thing I wanted to say that I want to kind of caution against if you're sailing to like uncharted waters, there's like a temptation to use something familiar and say that, oh, like the future is going to be just like this. Like the most common one is that, oh, AI is just a technology. It's just going to be just another like electricity or something like that. When we are talking about risks, the way the model risks is by the reference class that you cannot rule out. So as long as there is like reference classes like viruses, self-replicating things, or another species, as long as you cannot rule them out, you have to like prepare that this might be an instance of such thing. So I think it's important to not dismiss AI as, oh, it's just another technology, or like as one prominent VC recently said, oh, it's just a bunch of math.
Thanks, Jaan. Next, we're going to hear from Max Tegmark. He might describe what he's got on his chest. I happen to know he has released a very interesting TED Talk, which I strongly recommend all of you watch. And Max might give an abbreviated form of that TED Talk now, or whatever else you'd like to put in the conversation.
Thank you, thank you. Yeah, so I'm Max Tegmark. I've been doing AI research at MIT as a professor there for many years, focusing on safety-related stuff. I'm also the president of the Future of Life Institute. And I'm a huge fan of this guy, who you guys have the wisdom to put on your 50 quid note, Alan Turing, who's come up many times. And it's really remarkable that the argument he made 72 years ago, that when machines greatly outsmart us, by default they're going to take control, that argument has not been convincingly refuted in the 72 years since he said it. So I think we have to take it very seriously. And people who think of AI as just a new technology like steam engines or electricity tend to not take it so seriously. Alan Turing himself clearly thought about AI more as a new species. And with that framing, it's very natural that we would lose control to them, just like the Neanderthals lost control to us, etc. So what are we going to do about this great threat? First of all, having conversations like here and what happens tomorrow is great. So a huge thank you to the British government for really putting this on and for standing up to all the lobbying pressure from companies who wanted to water it down into just a big blessing of responsible scaling or whatever. Thanks also to the US government for standing up to also the weird pressures to turn this into a geopolitical pissing contest by excluding China. I'm really proud of the Brits for recognizing that this is a global challenge. And what do we actually do about it? Well, I think there's a remarkable consensus actually emerging from all the civil society and academic groups that don't directly profit the way companies do about what we should do about this. We put out maybe Andrew Critch or Richard Molly can just hold up in the air with this thing. You can, if you go to futureoflife.org/SSP, you'll find the alternative to the responsible scaling policy called the safety standards policy, where the idea is, as we heard from Stuart Russell, you simply shift the responsibility to companies to prove that things are safe. Instead of, as with responsible scaling policy, you have the responsibility on the government regulators to prove that things are unsafe, more or less, in order to stop them. And there's a whole set of very concrete ideas out there for what the safety standards should be to start with. And some of them were mentioned very eloquently by Stuart. You can insist on quantitative safety bounds or provable safety, beginning with uncontroversial stuff that you should not be able to demonstrate that nobody can hack the servers that these super large systems are on, that they won't advise on how to make bioweapons, etc. And this will very naturally accomplish something quite wonderful, where we sort of have the cake and eat it as a species. Because most people I talk to don't realize that there are two very different kinds of AI that they keep conflating. There is the AI that has current commercial value for curing cancer, making safer cars, and all sorts of wonderful things, which have very little risk associated with them, but some, which we need to address. but 99% of the things that most people are excited about do not require playing Russian roulette with AGI and superintelligence. And then there is this lunatic fringe obsession to try to build machines that outsmart humans in all ways, where almost all the risk is coming for very little benefit. So if we can put safety standards in place, we can, I think, quickly get into a situation where we have a long future with these wonderful benefits that are quite safe to get from AI, and then just take our time with the really risky stuff. Maybe one day humanity will or will not want to build more powerful machines, but only when we can figure out, how to control them. So I would end with just a bit of wisdom from ancient Greece, if I may. So raise your hand if you remember the story of Icarus. Don't get hubris, right? So artificial intelligence is giving humanity these incredible intellectual wings with which we can accomplish things beyond our wildest dreams. If we stop obsessively trying to fly into the sun. Thank you.
So you're not saying pause AI, you're saying let's keep using AI, but you're saying pause the rush to AGI.
Exactly. Let's not pause AI. In fact, let's continue almost everything that people are excited about doing, but pause this compulsive obsession about training ever more ginormous models that we just don't understand.
Thanks. Andrea Miotti is the head of policy and governance for AI at Conjecture. Are you in agreement with what you've heard, or you have different things to emphasize?
Absolutely. I'm very much in agreement with both the speakers and many other members of the panel. I think there are two big positives from the summit to highlight. One is that were also echoed by the panel. One is its role in building common knowledge, making it clear and explicit at the highest levels of government that this is a big risk, that this is a extinction level threat that we face as a species. And number two, coordination, not getting lost in a geopolitical pissing contest, as Max has said, or in other of these things, and realizing this is, again, a threat we all face together. It's a global security problem. It's not a national security problem, or at least it's not only a national security problem. And to solve these problems, we need coordination. Even during the heights of the Cold War, there were open lines between the US and the Soviet Union to deal with nukes. Closing the door on cooperation before it has been tried is a surefire way for all of us to lose. And so I was very, very pleased to see that the UK government, the Prime Minister Rishi Sunak, have already acknowledged the risks very explicitly in the Prime Minister's speech last week, are setting up this summit, are inviting a diverse group of countries to discuss this risk together. The part where I think we can go further and we can do better is in the measures. I share the concern of some of the other panelists on a focus on simply enabling the default to continue. And the reality is that the default is bad. The default is bad. We, by now, all understand it is bad, and we all understand we need something else. Even the companies racing towards its default admit that it's bad, admit that it's a 1 in 4, 1 in 10, unacceptably high chance for all of us to be wiped out. And so the concrete measures that we will need to take cannot look like continuing on the default path, cannot look like systems are safe until proven dangerous by external auditors that are strapped for resources and they don't even have the tools or the tests to do these tests. They look like provably safe systems. They look like burden of proof on developers, developing systems that they admit could wipe everyone out, to demonstrate ahead of time, ahead of running critical experiments, that they are safe. If they cannot do that, that's fine. They can just build something else, or they can move to a different sector. That's the standard we utilize in all high-risk sectors. There is no reason to not utilize it in a sector where the risks are the literal extinction of humanity. Thank you.
And last but not least, we have a trained economist, Alexandra Mousavizadeh, who is the CEO of Evident. What would you like to add to the conversation, Alexandra?
Well, it's a great panel to follow it. So it's, I have a different time horizon. I'm Alexandra Mousavizadeh. I'm the founder and CEO of Evident, and we actually do a lot of measurement. We specialize in benchmarking businesses on their adoption of AI. So what I focus on is very near term. So looking at the here and now, and the race is on at that level as well. So the race is on by all businesses in all sectors to take the capabilities that AI offers today and to implement it as fast as possible, and really not thinking about any of the risks. So thinking about growing market share, upping revenue, cutting costs, and all of that, and continuing the sort of digital transformation, which is now more and more an AI transformation. And so with that, we are observing this AI race at a business level. And one of the things that we see that some businesses that are highly regulated really think about how they can implement the oversight and implementation of safe AI. So while I'm very impressed with what the UK government is doing, and I think the right thing is to focus on the long term, because that is where we should have our eyes at this stage, but there's also a near-term risk. And I think if there was one thing I would suggest is that as much as we need to focus on the long term, we also need to look at the here and now, and that businesses are barreling ahead with AI adoption without any particular guardrails in that. And so while we need to put the burden on the development of safe AI, we could also maybe in the meantime put the burden on the businesses that are using AI to prove that they're doing it in a safe and constructive way.
Thanks. So you've heard from all the panelists. I'm sure there's lots and lots of questions in your mind. So I'm going to come to the audience and take maybe 3 or 4 questions and then let the panelists pick what they want. And my question would be, do you agree with this division between near-term and far future? Some people say that the risks from existential risks should not be considered to be long-term. They are potentially here and now, but maybe you have a different way of framing it. Let's see some hands. Let's take one back over there in the far corner. It's a bit some running around. If you like, you can say who you are. If you want to remain anonymous, that's fine too.
Hi, I'm Matthew Kilcoyne. I was wondering, the time horizon is really fascinating, but also horizons are also really fascinating. I was wondering if you'd ever looked into how the banking industry turns short-term into long-term by sort of senior management risk and associated penalties and clawbacks to sort of force the change.
Thanks a lot, everyone. Yolanda Lanquist from the Futurists Society. What do we do about open source AI? Professor Russell mentioned one idea, which was kill switches. I think this is, in terms of policy approaches, such an important question for us to all grapple. And again, as Jaan was saying, technology, people assume that paradigms continue. Open source has been valuable for software, but with AI, we're seeing new risks and paradigms, and how can maybe academia and others change a cultural norm that's important there around risks?
My name's Oliver Graves. My question is, what do you think the biggest hurdles are towards getting the general public to recognize this as an existential risk and to take that risk seriously? Because it still seems to me like it's all well and good, everyone here at the summit and in this room being aware of that risk, but it doesn't seem to me like we're anywhere close to a level of majority of the general public grappling with it properly.
Thank you. So I'm Father Peter Vignansky. I'm engaged in looking at how the Catholic Church can respond to existential risks. So a slightly different question here. Just in the most general way, what does it look like from your side of the table for religious groups to play their part in achieving existential security?
Thank you. Oliver Chamberlain. I'm a student studying a master's in science in AI. One of my concerns is, although the regulation is going to involve limiting supply chains, making sure that GPUs aren't going off to places that we don't know about, how do we stop the advancement of algorithms which allows older systems to be more powerful? So like alpha, tensor. I wonder, in my mind, the only way around something like this is a future which is super draconian. how do we prevent GPUs that are already accessible, already out there, from being used in ways which are way more powerful?
So, Max, hand up first.
Yeah. Religious organizations, I hope, can remind us all of the importance to not play God and get hubris. Remember the moral angle. I'm only going to comment on the timeline one, even though I have opinions about all the others, so I don't talk too much. The timeline one, from Alan Turing's perspective, when he said this, he said that when we eventually basically passed the Turing test, he expected to go very fast. So then it was a long-term risk. Now, according to Joshua Bengio, GPT-4 passes a Turing test. So he would probably, if he were still with us in the room, predict a short timeline. It's quite remarkable what's happened on the prediction market, metaculus.com, for those of you who are nerdy enough to go there, where the timeline, how many years we have left to artificial general intelligence outsmarting us, has plummeted from 20 years away to 3 years away, just in the last 18 months, as a direct result of this recent tech progress. And Dario Amodei has openly said, one of the tech CEOs here, that he thinks we have 2 or 3 years left, and other tech CEOs have told me that individually. So I think we just have to stop calling this artificial general intelligence risk long-term, or people are going to laugh at us and call us dinosaurs stuck in 2021.
Andrea?
I'd like to answer the question about the public. Actually, the public seems to really understand. I recently ran polling as part of a campaign I'm running called Control AI, and the British public is extremely concerned about disempowerment and extinction risk from AI. They seem to be aware of it. A whopping 60% would like a global ban on smart and human AI, period, with only, I believe, 14% against, and like quite a few undecided. I believe almost nearly 90% would be very, very happy with a full ban on deepfakes right now. People understand very, very well that full impersonation, revenge pornography, and like use of their likeness against their will is not good, is destabilizing, is a threat that exists right now with systems over here right now, and they don't want that. And similarly, there is, I believe, 78% of the public would want an international watchdog with real teeth, more like an IAEA for AI. And there are basically across the board, like I was personally surprised to see all of the answers come up with such overwhelming support. There's been recent polling in the US that shows very similar results from the AI Policy Institute that you can check.
We might ask whether that mood is shallow, that it might be adjusted again in the future. Let's hear from Annika, and then from Hal, and then from Jaan.
Yeah, I just wanted to say that we should stay away from predictions with regard to timelines, with regard to sectors, how they're going to be affected. I think if we have learned one thing, that it's really difficult to assess that. But we do know that there will be dislocations, there will be impacts, and as they grow and as we see them more, the public will be more informed and more aware. I think it's really our role here as civil society, academia, religious leaders to increase that awareness and to also keep that conversation going as we go. When you drive a car, you don't just look ahead, right? You also look in the rear view mirror, you look in the side mirrors for signals of change. But what I want to say, when you look back, that's something we are not doing enough. We're trying to predict in the future, but we should also look back and look at stuff we've put out there, regulation we're putting out there, and how it's actually being enforced, if it's effective, if it's effective regulation. We discussed about it before, and this will be key going forward.
I'll take the question. Oh, yeah, on? Yeah. I'll take the question on open source and draconianism, because I think they're related. I don't really see a good way of regulating and controlling open source code that is not deeply draconian, that does not involve a massive expansion of surveillance. If you need to know what code is running on what chips, you have to have access to the computer in which those chips are running. And for a sense of how well this is going to go, look at America's attempts to put export controls on Chinese AI development. It works to an extent, but it only works if you pick these very narrow bottlenecks. And I guess in terms of existential risk, it depends on how powerful sort of lower tier open source models end up being. I don't really have a good answer to that question. I'll just say one more thing on Metaculus, just as a little hint of not relying on it too much. If you remember the LK99 superconductivity thing over the summer, Metaculus at one point was completely certain that that was real. And Metaculus thought it was real for a while. And then it dived again. So just you can't rely on Metaculus too much.
We're going to do some real-time checking on this. Right. So whilst that's going on, Jaan?
So I also wanted to say a few words about open source. I think it's, as I mentioned earlier, I think it's important to just like not do this kind of categorical thinking that you have like some one particular kind of bucket that you put things into, and then like you reason about this bucket. My friend Andrew Critch, who is in the audience, like he observes that like when people say that they're really kind of pro open source, it's valuable to try to understand what they actually want. What is the thing that they're trying to protect? And quite often it's just like they don't want this like massive centralization and power in the hands of people that they don't trust. Now the question is like, if you think about open source as like irreversible deployment of things that we potentially don't want to irreversibly deploy, are there other ways to protect what the open source advocates want? And for example, there is like in blockchain community, there is quite a lot of advancement in cryptographic techniques, techniques like zero-knowledge proofs. Perhaps there are kind of like ways how we can kind of eat our cake and keep it too, by instead of having nosy people literally looking around in a computer, you just computer automatically producing things like zero-knowledge proofs that you haven't been up to no good, or things like that.
So there's lots of possibilities to explore there. Alexandra?
I'm actually curious about what Max and Hal were talking about.
AI secrets.
Did they know or did they not know?
They said it's about 60. At the peak enthusiasm, they thought it was 60% chance to be right, which I would say interpret as that they were not saying for sure it's right.
Okay.
But
prediction is very hard.
It's real-time checking here.
Prediction is hard. Canary signals are more important, in my view. Let's agree the canary signals.
If I can just add something here. When we ask if something is a near-term or long-term risk, we have to remember we're not asking if we know for sure that we're going to get superintelligence soon. If we think there's a 10% chance that something like this might happen in 4 years, right, then it's still the risk is near-term, even though I hope as much as anyone that it actually won't happen for a long time.
So Alexandra, and then Ron, and then Mark.
Yeah, I just wanted to respond to the question on the banks. If I understood it correctly, it was like, was that maybe a model of regulation for AI? Is that what you meant? Okay. I mean, as we cover that sector very deeply, it is an area where, I mean, and it's a sector that is heavily regulated, and because they're heavily regulated, the way that they are developing and deploying and implementing AI today is that even as they develop, there's a lot of oversight in the models themselves, and then they go through first and second and third lines of defense where there is oversight again, and then they submit to the regulators. And in a way, I mean, I can't believe I'm saying this, but in a way the banks could be a model with which, if you are to impose a oversight at a company level, for the AI that they're using, the banking model is not a bad one, because the way that they assess the risks as they go from development to deployment into production and output. So that could be a blueprint or something to look at for businesses themselves, to regulate themselves, if that's where we end up.
So there might be something to learn, but bearing in mind AGI is different from everything that's ever been before. Ron, what would you like to add?
Well, I'd like to come back to the discussion about open source versus closed source. And I'm a bit surprised that here at the table there is a strong belief in closed large company models that might contain lots of 0 days we don't know of, instead of trusting civil society. And on regulation, we therefore not only need to regulate development, we also need to regulate use. And that's what the AI Act does, for example.
Sounds like none of the old traditional models are going to work. Sounds like we need something that has a variety of different approaches. We have to transcend some of the previous systems. And Mark, and then we'll come back to pick up a few more comments.
Yeah, I just wanted to pick up on sort of the question of near-term or existing harms that we see and sort of harms in future, because I think what you saw yesterday with President Biden coming out with an executive order in the United States, as well as with the EU AI Act, which has been a long time in the making, you see sort of an attempt, and I think a successful attempt by policymakers to tackle both AI and bias that you see in current day applications and some of the risks that are that are AGI related. And I think that shows that it's perfectly possible to do both. And I know a lot of people in this audience are potentially driven by existential risk. I mean, that's why we come to an Existential Risk Observatory event panel. But I think there is a lot of alliances and bridges that can be built across that space. And I think it's often not helpful to look at both of these things. Maybe just on banking. I mean, we've seen the 2008 financial crisis, where I think lots of people were justifiably angry because CEOs got away with whatever they were wanting to do, and governments bailed out the banks. There was briefly a lot of regulation that was then rolled back over the past few years, and again we saw a few small banks collapse in California. So I think we need to learn some lessons there around liability and making sure that as we build a liability regime for AI companies, CEOs are also individually and criminally liable if they are indeed negligent or if there are sort of safety risks that they're ignoring. So maybe just to add on those 2 points.
So half the panel have got their hands up wanting to speak, but I'm going to ignore them briefly and give the microphone very quickly to 3 people in the audience. But you have to be quick because we're out of time already.
Thanks, Richard Barker. And Ron introduced the analogy of the pharmaceutical industry, which is not perfect by any means, but I spent most of my career in it. So if I can distill a few lessons from that, right? The first is you regulate not the underlying technology, but the application of the technology. So it turns out thalidomide is a terrible thing to give to pregnant women, but it actually cures people with multiple myeloma. So I can't imagine how we're going to actually deeply regulate the internal workings. It's how they're used. And it may not be existential risk that is most relevant to actually harnessing public opinion. It will be some of the things that's already happening that affect them personally. And so that my final comment is we need objective measures that not just experts, but panels come back to legislators and say, this is what I saw and this is what I like and don't like.
Terry Raby, former risk manager. Guys, you really need some pushback. I was deeply appalled at Stuart's example of the nuclear industry. The regulation of the nuclear industry in the United States, essentially, is anti-human. It's prevented the gifts of energy that's not polluting by regulation. We have another anti-human example of regulation in the EU, which is a regulation of biology, destructive of the advantages that we could get from genetically modified organisms. So look, it won't do. There needs to be a little bit more pushback to you guys so you get your story straight.
There was a hand here I saw earlier.
Thank you. Tony Shamneski, Sustensis. Professor Russell made a very important distinction about AI to be safe for humans and AI safe for use as a tool. The first one is a new type of intelligence. The second one is just used as a tool. So that's where the regulation comes in context. We can regulate AI as safe to use, and we must have a control of AI development so it doesn't become an existential risk. My question to the panel is the following one. Is it possible, or should it be possible, in order to avoid open sourcing problems, to develop just one super intelligence program that will beat any small guy's developments, and in that way make us safer? And the second question is, what will follow this summit deliverable, which is apparently IPCC-like organization?
Thanks. So plenty to talk about there. Learning from the pharmaceutical industry, regulating apps, not platforms. We had Terry pushing back quite hard, saying, goodness, look at the mess of regulation in the nuclear industry and in GMOs. We had Tony asking about a unified approach with one research and development program, and also what's going to happen next. So 30 seconds each. Max, his hand up again.
I have a good friend in the American nuclear industry who told me that what really killed it wasn't regulation, but it was Fukushima and 3 Mile Island. For open source, 20 seconds on that, I actually think I love open source almost as much as Jan LeCun. MIT is the cradle kind of open source. But obviously, we don't open source plutonium, enriched uranium. And similarly here, we should get away from this childish debate about whether we open source nothing or everything and just ask where the line goes. Finally, there's a technical solution, I think, to this, which is not creepy, but still works, which Steve Omohundro and I wrote a paper about, where you actually have control over your own hardware chips, you own it, no government doesn't see what you run, but it's just not going to run certain kinds of really creepy code because the hardware itself won't do it. It's like a virus checker in reverse, where if your code can't prove that it's not making bioweapons, it just won't run.
So you can find out more about that proposal if you watch Max's TED Talk. Hal?
I was just going to ask, doesn't that make it a backdoor in kind of the same way that CSAM detection on iMessage makes it a backdoor?
No, it's completely decentralized. No one has access to your chip. It's just that if you want a chip that will run the harmful code, you have to make your own chip.
So we need standards for hardware, which is what Stuart was saying.
Yes. Who's going to jump in next? Andrea?
Just a quick reply to the IPCC model. I very much hope that we will not have an international agency model after the IPCC here. We are in crunch time, and we have now knowledge of the risks, and we have common knowledge about the risks. The role of the IPCC was a great organization to build over decades, essentially expertise and information to governments to deliberate on how to act. We do not have decades, and we know what the problems are. Governments are already acknowledging what the problems are. We need action, not a yearly report.
Alexandra?
I would agree with that. I think we're at a point where, and also I don't see how it's practically going to work. I mean, are the Chinese and the US going to open the kimono and submit to a UK body that wants it to, and no accountability and no repercussions if they don't? So I really don't see how that would work. But there's so much to say and so much to respond to on this. But I think gentlemen in the red jumper there very much agree with the fact that at least until something has taken place on the regulation and we've agreed to what that might look like for the near term, big risks, but for the here and now, make the companies, make the sectors accountable for how they use it. Make the buck stop there first, and then we can figure out, or in parallel figure out how to regulate sort of the bigger questions and the things that are giving us pause.
I don't think the world will submit to a body that's run by the UK, but the world might cooperate with a body that the UK helps to inspire and get off the board. Mark, your hand was up.
Yeah, I also just wanted to pick up on the question the gentleman in the red jumper raised on sort of parallels with the pharmaceutical industry. Yeah, you're just sort of a shining beacon here in the audience. I mean, I think on the one hand, like the time where everyone just could produce whatever potion they wanted to and put it out on the market, that has disappeared, and I think thankfully disappeared. And I think that there is lessons we can learn in that in terms of potentially licensing or making sure that you guarantee that something's safe. When it comes to regulating the application of AI, I think I'm significantly more skeptical. This has been, for example, in the Senate hearing, this was what Christina Montgomery from IBM was pushing quite heavily. We see on both sides of the Atlantic, big tech really pushing for application-based regulation, because that often means that the underlying big systems that they are building won't be regulated, right? Because how do you regulate GPT-4 if you only regulate applications and it's only the hospital that then integrates it into a chatbot for patient contact that actually has to deal with the regulatory burden. So I think you do need to force these big tech companies to do risk identification and mitigation, even if they can't particularly specify, oh, it goes into that application or this other one. So I think you need a bit of a combination of both.
Annika, are you a fan of the IPCC model, or would you prefer the ICFG model,
Or the IEA, I think. There are a couple of models proposed. I think what's important is to not put it in one hand, not in the hand of a few corporates, but also not in the hands of one state. So the current race is not healthy, and we need to think about how we get them back to the table. I know you have some ideas about this, and yeah, we are, as ICFG are trying to show and build the scenarios to explain what it means to look at a future where emerging tech is governed, and what it means when you look at a future where emerging tech is not governed, and that this will hopefully help decision makers come together and work together.
Because there are many other emerging technologies that might disrupt our society in many other ways too, just around the corner.
Absolutely. So we had this discussion shortly before the panel because, AI is, of course, a turbocharger for a number of technologies that are being developed at a fast pace. So we are also looking at neurotechnology and quantum and biotech. And I mean, a lot of here in the room are looking at different technologies, but the power will come from the combination of those, and they're also around the corner.
Ron, final remarks?
Yes, it works. First, I agree that we should both look into both the models and the applications, not one of them. But what I think is that we need science, but we do not have decades. So we need some sort of form of a rapid response mechanism, and in that we need a credible helix. We need both government, civil society, we need science, and we need all of them at the table.
Thanks. Closing words, Jaan?
Okay, one thing I would say about the regulation issue, I think my friend Zvi Moshevitz, he has this concept of dial of progress, that a lot of conversations end up in like, do we need more progress or less progress? Which is kind of like way too black and white way of looking at things. What you actually want to do is like look like there are different ways where we want more progress and different places where we want less progress. So it's actually completely consistent to believe, as I believe, that yes, we have over-regulated a lot of things in a way that is kind of detrimental for us. But that doesn't mean that we really should stop regulating things, new things as they come up.
Thanks. So please stay on the stage for a moment. We're going to have a few closing words from Otto, who is the head of ERO, which is part of the organization that has made this happen. Otto, are you here? Yes. And by the way, this discussion is a prelude to an even more important discussion, which is going to be taking place in the pub, in the good old British tradition. Afterwards, some of you might want to join us, where we can get round to all of you who had your hand up, and I unfortunately couldn't take your question. Otto.
Thank you, David. Sorry. Yeah, thanks, and thank you all of so much for being present here today. As some of us has already mentioned, we're here in Wilton Hall. This was built in 1943 as an assembly hall for the World War II codebreakers. And while deciphering the Enigma, they also built one of the first computers. And since then, computing and AI have progressed beyond imagination. And we're on multiple exponential curves here. Hardware, data quantity, algorithm capabilities are all growing with tens of percentage points per year. So I think we all, or at least a lot in this room, will suspect where this leads, which is AI that has the capability to do mental tasks much better than we can. And of course, this presents amazing opportunities. But according to most existential risk experts, we also risk nothing short of human extinction here. And it does mean that our species is on the line. So when I turned on the radio last weekend, the BBC was discussing human extinction by AI. And I think that this was dramatic, but also hopeful at the same time. So I thought this was dramatic since human extinction, caused by our own actions, is now officially a possibility. And it never ceases to amaze me that we have been stupid enough to let it get this far. But hearing this discussed on national radio, for me, was also extremely hopeful. Because up until now, attempts to reduce the real human extinction risks were minor, and world leaders were not paying attention. And with the summit that's starting tomorrow, I think this is really changing. So I think it's hopeful that after the UK's Prime Minister's speech on AI last week, in which he explicitly warned of human extinction risks, the questions that followed from the press were no longer about Prime Minister, is this a real concern? Shouldn't you be concerned about the bills of your people instead of this? But instead, at least some of the questions were about, are you addressing this problem seriously enough? And shouldn't we consider instead pausing AI, a moratorium, or are you doing the right thing with backing responsible scaling? And I think this is exactly the debate that we need. So I think it's now important that we continue in this direction. So we must organize AI safety summits much more often. We must open them up so everybody gets a say. We must have societal debate about this. And I think in general, we must come together to coordinate. And if we do that, we are confident at the Existential Risk Observatory that we can implement the measures that are needed. And this is why we have organized this event. And I think it's a huge privilege that we're able to do this together with Conjecture. So thank you so much for co-organizing this event. And we also want to continue organizing events like this one, but it's impossible without the support of all of you. So if you want to support us doing this, there was a flyer that you got handed at the beginning. Please scan the QR code there, and there's possibilities to support us. Could be with funding, could be with volunteering, could be with just following and sharing our content. So this is enormously appreciated. And with that, can I please get some applause for all our amazing speakers? Professor Stuart Russell, Connor Leahy, Professor Max Tegmark, Jaan Tallinn, Annika Brack, Mark Brakel, Ron Roozendaal, Alexandra Mousavizadeh, Andrea Miotti, and Hal Hodson. Please don't stop clapping. And finally, a special thanks as well to David Wood, our moderator, Ruben Dieleman, Katrina Jocelyn, Connor Exiotis, Sue Chisholm, Tilman Schepke, Niki Drozdowski, Mark van der Wel, and Joep Soeren, and everyone here at Wilton Hall who made this all possible. Thanks a lot for helping us out.